Welcome to the Rotary Academy YouTube channel, where we present information that helps you improve your understanding and knowledge about power electronics technology and its emerging applications. Today, we will focus on the commercially available Volkswagen ID series battery electric vehicle models. Today, we will focus on the power electronics technology associated with Tesla Model S. Volkswagen ID.3 battery pack. Let's consider the Volkswagen ID.3 battery pack. The Volkswagen ID.3 lithium-ion battery pack has a capacity ranging from 55 kWh to 82 kWh, while the voltage level of the battery pack ranges from 350 volt to 410 volt DC depending on the car's performance. Furthermore, the battery pack weight ranges from 206 kg to 310 kg depending on the number of cell modules in each battery pack configuration. The Volkswagen ID.3 battery pack consists of 8 major parts. Also, it is important to note that the Volkswagen ID.3 offers a 3 battery size choice depending on the battery capacity, i.e. 55 kWh, 62 kWh and 82 kWh. The first major part of the battery pack is the upper part housing of the battery pack to protect the battery cell modules, battery management system and many more sensitive parts of the battery pack. The Volkswagen ID.3 battery pack consists of battery cell modules. Therefore, a battery cell module consists of 24 battery cells. To create a battery pack, these modules are put together, and the number of the modules put together depends on the battery capacity of the electric vehicle. Also, we have the cell management controller, which is a critical part of the battery pack. The battery cell management controller is designed to address safety risks related to the battery cells by accurately controlling critical cell characteristics, voltages, temperatures, current, and by providing embedded balancing functions along with extensive system diagnostics. Also, the cell modules are connected to form a high-voltage battery pack through the high-voltage connector and the connector strip, which has been illustrated in the battery pack of the Volkswagen ID.3. Also, the battery management system, BMS, monitors the voltage, current and temperature of the battery pack and while continually optimizing battery performance. Then the battery pack of the Volkswagen ID.3 consists of the base plate with a cooling system, battery housing at the lower section of the battery pack, and underbody protection is illustrated. The battery pack consists of the NCM712 battery cell, with 24 battery cells making a battery cell module and about 12 battery cell modules making the battery pack depending on the battery capacity. The NCM712 cell is a pouch battery cell manufactured by LG Chemical. The N stands for nickel, C for cobalt, and N for manganese, while the 712 represents 70% nickel, 10% cobalt and 20% manganese. In general, the higher the nickel percentage in the battery, the higher the energy density that the battery can provide, with a profound positive effect on the battery pack's weight and dimensions. Each NCM712 cell nominal voltage makes up to 3.66 volts with a capacity of 78 ampere power, top. Energy density of 265 watt power. Also, each cell charging voltage makes up to 4.2 volts. There are 3 types of battery packs configurations that are expected to use in Volkswagen ID.3. The battery pack configuration 1 consists of 8 cell modules, 192 battery cells, a battery voltage level of 350 volts, can travel a range of 247 miles on a full charge, weight of 206 kilograms, and battery capacity of 55 kWh. The battery pack configuration 2 consists of 9 cell modules, 216 battery cells, a battery voltage level of 350 volts, can travel a range of 277 miles on a full charge, weight of 232 kilograms, and battery capacity of 62 kWh. The battery pack configuration 3 consists of 12 cell modules, 288 battery cells, a battery voltage level of 408 volts, can travel a range of 368 miles on a full charge, weight of 309 kilograms, and battery capacity of 82 kWh. Battery system consists of the following. The cooling system in Tesla Model S is based on propylene glycol, which acts as a coolant. To improve the heat transfer efficiency between each battery cell and the battery cooling system, the coolant tube running inside the battery pack has a wavy profile. Such a profile increases the contact surface between the battery cell and the coolant tube. Battery management systems, BMS, is the most important component in a battery pack, essential for the battery pack safety. The BMS used by Tesla in Model S is based around Texas Instruments BQ76PL536AQ13-6 series cell lithium-ion battery monitor and secondary protection. The red encircled area of the BMS shows that it contains 6 monitoring ICs for each series connection in the module. The yellow encircled area shows the terminals where the connection from the 6 cells will be connected. The IC by TI used in the BMS can be daisy-chained to need only one communication connection to the system. The BMS is integrated into every module and monitors the battery life, temperature, and charge-discharge cycle of cells. The Tesla Model S consists of a battery pack with 18,650 lithium-ion battery cells. The cells are cylindrical in shape and have a dimension of 18 mm in diameter with 65 mm in height. The nomenclature of the cell can be easily understood by splitting the numbers into 3 parts. The first 2 numbers tell us about the diameter of the cell in millimeters, the third and fourth numbers tell us about the height of the cell, while the last digit tells us about the shape of the cell. At a nominal voltage of 3.66 volts, each 18,650 cells can be charged as high as 4.2 volts, with each cell storing up to 3,400 mAh. Each 18650 cell can be discharged as low as 2.5 volts. The Tesla Model S uses multiple 18,650 cells to make the battery pack. But rather than arranging all the cells and making a single big battery, Tesla uses multiple smaller batteries called the battery module to make the final battery pack. Each battery module is based on the 6S74P configuration, in which 6 battery cells are connected in series, and each of these series has 74 cells connected in parallel. Each of Tesla's modules is rated for 500 amps of continuous current with 750 amps of peak current. There's a liquid cooling integrated to maintain the temperature of the battery pack. The pack has a configuration of 6S74P, and which makes the total number of cells to be 444 cells in each battery module. The cells are arranged with the positive or negative terminals facing up in a specific pattern to achieve the desired voltage and capacity for the battery module. The red cells indicate cells whose positive terminals are facing up, and the white cells indicate cells whose negative terminals are facing up. In a Tesla Model S battery pack, 16 battery modules are assembled inside a battery tray. Each of these 16 modules is connected in parallel to the central busbar in the battery pack through the M8 bolt terminals on the battery module. The battery pack central busbar collects current from all the modules and takes it to a contactor which feeds it to the electric drive. The next series of videos, the power electronics technology deployed in the other Volkswagen ID series will be addressed. Remember to push the like button, then the subscribe button, and press the notification bell. Your comments and feedback are greatly valued. Thanks so much for your time and support.